So this is another position versus time graph. Choose the correct answer question. It's a pretty complicated one, so let's take it slow, read through the question. We might need to read through it a couple times. Happens a lot with physics problems. But let's read through this and see if we can make some sense of what the words are, highlighting some stuff as we go. So it says that a car accelerates from rest on a straight road. And at that point, that was a lot of information that was given to us. We'll come back to it. A short time later, the car decelerates to a stop, then returns to its original position in the same manner, by speeding up and then slowing down to a stop. Which of the 5 following coordinate versus time graphs best describes the motion? Okay. Lot of information. Let's take it piece by piece by piece and start to highlight information. I'm actually going to highlight in a couple different colors because it's going to be useful for us. Highlight in 3 different colors. I'm going to use one color for acceleration, one color for position, and one color for velocity, position, and acceleration. So I see that a car accelerates from rest. From rest, this term from rest in here would dictate that our initial velocity is equal to 0. And it accelerates means that the acceleration at that point is not equal to 0. It gives me absolutely no idea of where we start. Nothing in green yet, nothing that's in the position area. A short time later, the car decelerates. So acceleration is going to be, assume that this acceleration is greater than 0. Assume that the acceleration is greater than 0. That means this acceleration would be less than 0. It decelerates to a stop. And again, we're back at some v1 is equal to 0. At some time later, what I'm calling v1, we're going to go to a stop. So a short time later, the car decelerates to a stop, then returns to its original position. Oh, this is a lot of information in this next little part. It says that we then return to our original position. So at a third time, or what I'm going to call time 2, we're going to return to our original position in the same manner by speeding up, then slowing back down. So this is giving us information about the original position. So that means our final position, our second position, is equal to our initial position. So whatever we do, we have to get back to the same position. It also says that we do it in a similar manner by speeding up, then slowing down back to a stop. I'm getting confused with my colors, but at the end, our velocity 2 is equal to 0. And here we have an acceleration greater than 0, followed by an acceleration less than 0. All right, let's try to make some reasoning out of this graph. See if we can't eliminate out some nice ones for us just to begin with. I'm going to look at at choice D, and I'm going to eliminate out choice D and actually pick the right color, because choice D says that our final position has to be equal to our initial position. We return to our original position. Well, this started up here and it ended at a different x position. So those two are clearly not at the same position. So we can eliminate out those. All right, let's see if we can't use some more information. I don't know anything else. This guy returns to its original position. Here returns to its original. All of these return to their original position. So they don't give me any information on these graphs of which ones to eliminate. All right, let's look at the acceleration. Let's see if we can eliminate some stuff out by what the acceleration does. Well, the acceleration, we accelerate, and we remember that acceleration is going to give us a change of velocity in a given amount of time. And we know that velocity, actually I should do this in a different color, my velocity is equal to a change of position in a change of time. So really what we're doing is we're looking at slopes of lines and slopes of lines. A little bit confusing, but we can get through this. So we start with some acceleration that's positive, and it's going to cause our velocity to pick up. If our velocity is increasing, it starts at 0 and increasing, that means our acceleration or our velocity can't be constant, which means the slopes of these graphs cannot be constant when we hit the acceleration. So I'm looking at this graph right here, and I'm looking at these have a constant slope. These values right along here have a constant slope. A constant slope of a position versus time graph would imply that our velocity is constant. Constant slope, constant velocity. We're looking at a position versus time graph. So this one does not work because the slope of the position versus time graph is constant. Same thing with this one over here. These slopes over here, all of the slopes here are constant slopes. If we look at the initial point even on both of these two, they don't start at rest. They start with some initial velocity. So A is wrong and B is wrong. And actually we can look at C, and because the slope at C at the very initial position, it says it starts at rest, but this graph does not start with a 0 slope. So C is wrong. So let's look at E. I hope E is correct or the problem is very poorly done. E, we start at some initial position. It starts with a very flat position. This is not going anywhere. So it starts at rest, 0 slope. At some point, we need to take the slope of 0 and make it into some positive acceleration, or it has a positive acceleration, which means we're going to increase our velocity. Over here, we look and we see that right in this little corner right here, our velocity goes from 0 to some value. It sits here. We slowly decelerate up here. So our slope goes from positive value, and as we go along the top of this curve, our slope will slowly go back to 0. So that brings us up to our V1. V1 equaling 0. It happens right at the top. Well, then we return to our original position in the same manner. We speed up. This is actually an acceleration. I marked this wrong. This acceleration should be less than 0, and we slow down. Speeding up and slowing down does not tell us the direction. So we're going to get faster, but it's faster in a negative direction because we need to return. So we're going to start with 0 velocity. It's going to speed up. It's going to get more negative. It's going to go along for a while along this graph, and then it's going to hit this bottom little curve right here, and it's going to be going down, down, down. It's going to slow down and eventually going to go to a 0 velocity, a 0 slope, or a velocity, a final velocity equal to 0. We ended up at our initial position. So E is our correct answer. Very complicated problem to get through this. But by just going through, breaking it apart, reading it 3, 4, 5 times through, we finally got to the right answer. So I encourage you to read the problems through, take a look at the graph, see what you're trying to figure out, then really dissect the problem. And you can see there's a lot of scribbles on here of different information that's given at different times.